My name is Jerry Cunningham. I am a retired UN Environment staff member. I worked 30 years at UN UNEP headquarters in Nairobi. I left in 2016 and I'm now director of an NGO dealing with SDG reporting called Eagles 2030. The title of this session, let me just get the title right. It's a long title. The title of the session is Big Data for Toxic Exposure Assessment and Prevention to make a safer world for people, environment and wildlife by 2030. So you can just meditate for a moment on the title of the session. So we're dealing with people, environment and wildlife. We're dealing with toxic exposure and prevention and a time scale of 2030. That is an enormous topic, but nevertheless a very important one. We are very pleased to have a distinguished speaker all the way from Tehran in Iran, and it's my pleasure to introduce Dr. Ahmad Mahdavi. Dr. Mahdavi, as I said, is based in Tehran. He's actually, like myself, he's also retired from the University of Tehran, where he was a professor of entomology and eco-toxicology. He's also a graduate, not only from his own university, but also from the University of Guelph in Canada. He's a member of the Entomological Society of America, and he is heavily engaged with the implementation of the Stockholm Convention on POPs, the persistent organic pollutants. He is the sole speaker at this session, and it's my pleasure to introduce Professor Mahdavi to deliver his presentation. Thank you for your attention.
Thank you, Mr. Cunningham, for introducing me. So my session changed the date or the time, in fact, and hopefully that now we will have some more audiences later to come from the launch. As you heard, the title of my session is about some kind of, can say, dangerous material that's been around, now for a century on the planet, and we have been trying all this time to put some kind of control and regulation on these compounds that they are already really damaging and destroying some biodiversity, some animals, making cancer and wildlife harm. And last year we find very shocking evidences about that. My talk, as you see here, is about introducing the big data that already we had very good presentation, and I'm happy that really I got the opportunity to speak from the microphone of the Eye on Earth that I respected so much, and Mr. Glidon really always, that later I point to the webinars. So I'm happy that I'm getting this opportunity to talk about these things, big data that is not, I'm not a statistician specialized, but I did lots of statistics during my high BS, MS in University of Tehran and later in Canada also. So I'm always very interested, but now big data is something that's really everywhere it is used. These are the overview of my talk that you can see. They are big data now. They are very important on this planet, including about the toxicology that we need. Really, we need to use them to be able to more control for toxic compounds. the big data now is about that we know what to do with them, not how much they are. These are too good, and it looks like oil that we have to refine it and change it to the valuable material. At first, as you heard in all sessions, there are big informations that very good presentations about the biology and biodiversity related to big data, about the genomics and the DNA coding of the all creatures. That when I was doing PhD, it started that time about 30 years ago, but now it's very developed. We have a huge amount of, fortunately, information about the biology and biotic system as a big data. And these are very important because many stakeholders are going to use them, for management of their natural resources. These are the webinars that Derek Glidden, that very good organization, organized very good, about once a month, and I've been following that regularly. This one was last year about the big data in biodiversity, and about how important they are, about the need also for the field assessment. We, at the same time that we have satellite data and big data available, we have to complement them with the field data also at the same time. This is a naturalist from Microsoft, that there is an alert about that if we don't do anything, we lose about 40% of the species by the end of this century. And as an entomologist, I'm already observing that some of them insects, yesterday I pointed that insects, from 3 million species, we have only 10,000 species of pests. So they are very important. And many other, creatures. We have cheetah, in Iran that, is so under only there. We have many birds. Many birds now under restriction. Vultures are vanishing. We talked about it last year. That's a big, very tough situation. We have to be careful. And about the UN lab, biodiversity lab, that this morning there was a very good talk. That is very important for mapping the platform. This interactive mapping platform offers a free cloud-based tool that can be used by very widely by biologists and toxicologists and other groups. This is about the exposure. It's some years that I am careful about the exposure. It was in my title, exposure of people, environment, and wildlife to toxic pollution. It is started about more than a century by industrialism, but it's really start maybe was but Mr. Muller, that from Swiss, that invented he didn't invent the DDT. DDT was discovered some years before that, in the past century before that, 18 something like that. But Muller discovered the insecticidal property of the DDT, and that started. Then Dr. Schroeder, the head of the ROPs, organophosphate pesticides, and that started one after each other. The real insecticides that are pyrethroids, after that was not supposed to be 50, 60 compounds, but now most of the insecticide, that's the pyrethroids. Anyway, that's something that's very developed. So there is a big exposure now to this and we have millions of chemicals. Pesticides are about 30,000 altogether, but we have millions of chemicals now and their metabolites. And POPs are something that I have a good experience about them. Persistent organic pollutants. POPs, with climate change, there are high possibility that this exposure to toxic and including to POPs will increase. And that's something that we have to be careful. Here in the bottom of the screen that you see with yellow here, nanomaterials. We have to be careful. Nanomaterials are expanding very much, and then not so much regulation in developing countries. It's going very fast. About even in big regulatory agencies like EPA, still about the food regulation of nanomaterials, it is on the stage of some kind of starting. So this is going very fast, world of chemistry for nanomaterials, but not so much regulation in food, in drug, pharmaceuticals, everywhere. And endocrine disruptors, bisphenol A that is around. Endocrine disruptors, lots of these compounds are going. Some years ago, I had a message that talking about that more exposure of people in developing countries. People in developing countries are more exposed to these compounds. And also, now these compounds now are found in all niches and habitats. So preventing since Precambrian, 300 million years ago, we have this expansion of species. But now we are going backward. And how many species are left behind? We are very worried about that. So the process of evolution and co-evolution is stopping because they are everywhere. Bits and pieces of these chemicals are everywhere now, threatening the whole creatures. This is the process of the exposure that you can see how it happens from the materials, and later integration. Okay, from here we enter the new world of toxicology that it's called predictive toxicology. Big data is already helping the predictive toxicology, and we have to use big data. That's what I'm speaking, because the old systems that we used, I used also during my PhD, not very old, very good bioassay system, replicated bioassays. They are not anymore accepted with these millions and millions of chemicals. We have to employ new methodological, statistical method and analysis method for the big data in toxicology. EPA still again is the going ahead and frontier. Actor is a program by EPA, and later ToxCast, that is a toxicity forecaster. These are all by EPA that is already started. It's some years that new methodological of toxicology is started and helping the big array of chemicals that is around. So we can use, as I said here, the availability of huge amount of different toxicological scientific information as big data, and new analysis methods are opening a new hope for better assessment of toxic exposure. And so possibility of preventing and reducing these exposures. These slides are some pictures about the problem and how we should deal with them. one after each other. This is the process that we have to follow. The important thing that happened in toxicology was in vitro assessment and measuring against in vivo. What I did also in vitro. You know, the difference between in vivo and in vitro is in vivo means that we test the chemical or pesticide on an intact animal, on a live animal, like mouse. I did on insects, thousands of insects every day, just shooting them to see what is the response. But in vivo goes to the tissue. So we need cell culture, different type of cell culture that you can see here. This is the new methodology, not very new. It's already started about more than maybe 10 years, but it's developing. And there are still lots of development needed. Stem cells, as you see, and the 21st century toxicology starts with the 21st century cell culture. Cell culture are very important, and we need that. This is the here metabolomics and omics, that including some parts that is very important in this research. Chemical watch, I'm following that for some years now. This is about news of toxicology and very important. These are the big data that are available in different literature, and in vitro toxicology, the literature that are available in different sources now, by mining, by data mining, they are available for decision making. It means that we have millions of papers and sources available, and by data mining, we can decide better which material is more toxic. Both in US and also in EU, as EPA, I was always learning and following EPA very good. But later, now I have more access to ECHA. Every year I go to Helsinki and about the regulation of these toxics. Nothing for business and money, just to help the people. And that is very important now. This is the work that I started in Canada about and my basic statistics, you know, science goes back to this, that we started with a very, very excellent scientist and very good man called J.J. Hubert with the book Bioassay. This is the work that we studied, and we developed some probit analysis system that computer analyzed. These were the starting of this science that later, this is the thing that we did. This is the paper, my paper, you can find it in environmental entomology. And we developed some formula here. You can see, perhaps this was the starting of big data. We never heard about the big data that time. But I combined LD50s. You know, for every toxic, we need LD50s and LC50s. And that time we managed with the Professor Hubert. He was not my professor, he was my advisor. Very, very good statistician. He wrote the book Bioassay, and my name is there also. So we developed that, and I wanted to point out to the synergism. Even though we have lots of chemicals and pesticides, they synergize each other. They synergize each other to a more bad effects. We have, and this is something that should be always considered, the synergism and synergistic effects. So this is, please, if you are interested, see the paper. And I put here alert, you know why? Last month, I observed that somebody added his name to our paper. I don't know how much this is usual. This is a paper that if you ever see it on environmental, I saw that 4 people, somebody, this is a very, very, bad thing that I am going to report it. Also, I reported already to the Entomological Society of America, that is publisher of the environmental entomology. I observed that somebody, there are 3 that I did, this is my work. Somebody added his name. I don't know how much usual is that this kind of fragiles, this kind of bad work, that I was very surprised of that. So this is okay. For the past 20 years, I've been working on pesticide chemical regulation. At first, I said, no chemicals. Chemicals are bad. And later that, okay, maybe after 30 years, before 30 years, that we see that, no, chemicals, we cannot put them away. It is in our life. Then I started as a regulatory scientist to regulate them. Okay, now that we have them, we have to be careful of them. Regulatory agencies need big data, and now they are using big data. EPA, REACH in Europe, that is going very good. CFIA and PMRA, they are in Canada, and many others. They are all using big data now for their regulation, because every day they get different type of chemicals, different type of materials, and also different type of requests from people and community, more regulation, more type of regulation. And they are also faced with the security data and personal data that sometimes is not exposed to them, and they don't allow them to work. So these are all things that involved with regulation, but is already in use. The big data is already in use by environmental health, safety, and security in the regulatory agencies. I pointed here at the bottom, please see, always in regulation that these years I'm following, we observed that EPA is working very good for US, or even ECHA now for Europe. But regulation stops at the border. And we have big problems in MENA and NANO countries, in Middle Eastern and North African countries. We don't need so much pesticide. Pesticide, whole world is needed about 25 billion, okay, say. But they are selling $60 billion pesticides. So more than half, more than twice that needed, really. That's all for money making and making cancer, destroying the wildlife. So that is something that is more than usual and more than use. Then, so regulation stops at the border, doesn't come to the developing countries. And that's why it's 20 years I'm trying to make a regulation. Maybe Mr. Glidon is aware about that. I'm trying to make, even with ECHA and in Helsinki, that the reach is very good. In connection, the head of ECHA that changed last year, we were in China just last year in a conference. Mr. Geert Danset, I told him many times that I would like to do something for people and environment in our area, because I am maybe the older scientist or maybe more experienced in this area. So this is something that I'm going to do it really to help this region for regulation. We do not have any enforcement. We have regulations in developing countries, no enforcement. When you go to enforcement, you see that, okay, nothing happens. This is my work that I pointed that I'm doing now for 20 years. I'm following up with no help, really no help, very poor life. This is my message that I sent 10 years ago. It is online. You can see it if you go to Google. How pesticides are handled in developing countries. That was a good message, about a paragraph. Negative. Last year, I had a talk in Toledo for CMS preventing poisoning, UNEP CMS preventing poisoning. we found that big effect and killing on birds and wetlands, in wetlands. And later in Manila, I couldn't go there. In the COP of CMS, just last year, the report is there that you can see the link here, and many of my comments are there. You can see in Toledo conference about that. Pesticides are dangerous material. A pesticide is designed to kill. That is something to consider, really. From hundreds of thousands of compounds, a pesticide on screening for just designed to kill. And then, so we need big data now. Really, the traditional data that we did that time, regular bioassays are not working anymore. And they are fortunately started very good. The EPA and other agencies are already, see here, now they are able to combine the in vitro throughput readings of in vitro assays, to combine it with literature, and see here, for example, 700,000 bioassays on PubChem and 600,000 compounds. Many data are available for different things. We are facing now with cosmetics, toxic cosmetics, that we are facing with different type of chemicals that all now need regulation and work. These are, see, all of them are, most of them, nearly all are pesticides. Still, the worst chemicals are pesticides. And that's how the data are increased this year to millions and millions, fortunately, data and published data, and they are all used by this screening system. They combine the lab data from in vitro assays with the publications, and very good results come out. I point to some of them here also. See, other than other things, the ethical concerns are important, and Natural Center for Computational Toxicology now is a very important term that is followed, and there are institutes about that now. Say 15, 9 million only, this is some years ago even, no more chemicals we have in literature and different places. High throughput measurement to identify exposure. We are not exposed now to many types of chemicals, and we need these new methodologies to follow the assessment. Computational toxicologies that is used now, ToxCast, as I said, by EPA, that developed now is helping a lot for this toxicity testing, using computational toxicity. And this is chemical testing in the 21st century that we needed, really. ToxCast, high throughput in vitro testing. As I said, in vitro is the working on tissues and lower than tissues, on molecules even, that we worked also. I try, if time allows now, to tell you that cytochrome P450 in all our body, in liver, is the main enzyme that stays in the front of toxics. Detoxification system of body is cytochrome P450. There are glutathione esterases and other. Cytochrome P450 I worked also, both in vitro and also in vivo and in vitro. We worked to compare, but that time now is very developed. See, the in vitro testing now goes to the enzyme levels, to the molecular levels, and can measure the whole things for toxicity, that to see how much a toxic is inhibiting. Cytochrome P450 is in whole life system, whole animals, even in some plants. And it is the most important detoxification system. How much time? Thanks, Tarek. Thank you. That anyway, I found the opportunity to speak about this important issue. However, this is the ComTox that later, including the ToxCast by EPA. Very good programs. And bioassays. See, we did that time bioassays, simple bioassays, but I combined them. Nobody, I was the first one maybe worked with US. I was in Guelph, Canada, University of Toronto, and we worked with Cornell and Michigan State and one university in Florida to do this. And now we have big bioassay data, very, very sophisticated biodata that, bioassays that is difficult. Bioassays are very meaningful and very complicated. Bioassays, at that time, I was able to say that I can test any chemical on any animal. I was really able. From the fly that I did to the even I claimed that I can do testing on whales, any chemical on any animal. That system. But now on the level of enzymatics, this is a big shame that I found in one of papers. This shows how combination of the in vivo and in vitro bioassays, some from the millions of tests finally gets to some results. And we found that what chemicals are toxic to our life and to our systems. So this is related to SDGs. I work on SDG 12, sustainable consumption and production. And hopefully we'll talk in the Nairobi in the UNIA 4 in March. I try to do that. A big part of the SDG 12 is chemicals and pesticide management is there. And so we hope that we will be able to manage these compounds more and better. This is using of big data in chemical safety that is already started by one of companies. Sensors are very important in companies for the chemical safety. Chemical companies are faced with safety, fire, toxication, and sensors are giving big help both for the safety and also for chemoinformatics. For chemoinformatics, for chemical discovery. Sensors are very wide and now are very helping in combination with IoT, Internet of Things, that they are all combined now very, very, and I love really to discover more about this system, to be able to better assessment of chemicals and better assessment, better finding of the danger incidents sometimes in chemical factories. This is big data for chemical chemoinformatics that I defined it. I find on Google this definition. Chemoinformatics is the mixing of information technology and management resources to transform data into information and information into knowledge. So this is chemoinformatics, a very important term in toxicology now that is partly of this science. REACH is following in Europe and echo that I said, REACH is following the big data also to manage the, REACH is, Europe is going the best now, then Australia, then North America, for regulation and for health and safety of people and environment. Europe is going best. And this is something that I did in Iran, using big data, IoT, and these things, and mobile technology in IPM. IPM, you know, is a method of controlling pests, not only with pesticide. So using that system for IPM and also sensors for the smart agriculture. Agriculture to be able to produce food production for 9 or 10 billion people soon. We need these technologies that fortunately is using very good in agriculture. Agriculture is managed, the agricultural system of the world to manage using these technologies very good. That is something that I go fast to the end, and thank you that anyway for the time. Mobile and sensors are very important. They come very tiny, but very big help in a smart agriculture. And these are some slides at the end about pesticide. Just when I was coming here, it was about glyphosate again. I'm sure you have heard about glyphosate. This is a talk that I had, and it is on my Facebook, this picture. If you see, there are big, big toxic in wetlands. And at the same time, you know, we have Wetlands Cup here in Dubai. And I'm participating, and I have a workshop there on 28. Please try to come to my workshop. This is lead, that is very important. Lead is one of the bad poisons that is destroying the whole thing. And this is my, I think, side event on 28th of October here in the, you know, festival city. A big conference like this is going there. And that's so good. They managed to bring the people, the whole science and this country really to her. Thank you very much.